All right, so this is going to be some questions from the Unit 2 exam. So we're going to start with this one. If the price in dollars of a stereo system is given by a P of Q, equals 1800 over Q squared plus 500, where Q represents the demand for the product. Find the marginal revenue when the demand is 10. All right. So the first question is, what is the formula for the revenue function? All right. Well, that is just RQ equals PQ. So let's go ahead and find that revenue function. So R of Q equals PQ, and P is 1800 over Q squared plus 500 times Q. Let's distribute that Q so that I get an 1800 over Q plus 500 Q. Now they want us to find the marginal revenue when the demand is 10. So I want to find the marginal revenue, which means I need to take the derivative. And that gives me negative 1800 over Q squared plus 500. And I want to find that when Q is 10. So I need R prime of 10. So R prime of 10 equals negative 1800 over 10 squared plus 500. All right, so that's going to be a negative 1800 over 100 plus 500. So let me cancel my zeros. So I have a negative 18 plus 500, which gives me 482. And that's it for that one. Next question. Find the value of the constant K that makes the function continuous. So let's just start by reviewing what needs to happen for a function to be continuous at a point. Well, I know that my problem point is going to be at 5. So for a function to be continuous at the point 5, first, f of 5 has to be defined. 2, the limit as x goes to 5 of f of x, well, I guess it's g of x. I guess I should rewrite these. G of 5, g of x has to exist. And 3, the limit as x goes to 5 of g of x needs to equal g of 5. All right, so what we have here is they're saying, okay, well, if x doesn't equal 5, use this. If x equals 5, then use this. We need for the limit to exist, and it needs to be defined. Okay, well, we know that it's defined because of this part, right? So what I need to have happen to find K, I'm going to factor this part, and it's going to factor so that this is a removable discontinuity. But then I can set it equal to this part. So the limit exists. The limit's going to exist from the left. Whoa. All right. So the limit's going to exist from the left or from the right, from this part right here. Right. The limit's going to exist from that part because it's just going to create a hole at 5. But what needs to happen is we need, I'm not going to say what the specific graph looks like, but what's going to happen is it's going to create a line and there's going to create a hole. What needs to happen is the point that comes from here needs to fill in that hole. All right, so we want to choose K so that it fills in that hole. That will make it continuous. So here's what I'm going to do. I'm going to factor that numerator. So I have a 2x squared minus 6x minus 20 over x minus 5. So I have a 2x minus 5. So there's going to be a 4 here. I have a negative 10. I need a plus 4. All right. So what happens is I end up with a line at 2x plus 4. And if I plug in my point, 2 times 5 plus 4, and I plug in a 5 here, I want that K value so that it equals exactly where that hole is. All right, so that's what we need to find. All right, so I get a 10 plus 4 equals 5K minus 11. So I get a 14, add 11, and that gives me 25. So K equals 5. If K equals 5, then I fill in that hole. All right, and that will make it continuous at that point. All right, next question. A 12-foot ladder is leaning against a building. If the bottom of the ladder is sliding along the pavement directly away from the building at 3 feet per second, how fast is the top of the ladder moving down when the foot of the ladder is 3 feet from the wall? Okay, so I'm going to draw a ladder. So this is my ladder. And here's my wall. And here is the bottom. And they say my ladder is 12 feet exactly. The bottom of the ladder, let's call this side X and let's call this side Y. The bottom of the ladder is sliding along the pavement directly away from the building at 3 feet per second. So it's moving this way. So dx dt is 3, and it's positive because that distance is getting larger. How fast is the top of the ladder moving down when the foot of the ladder is 3 feet? So I want to know dy dt when I want to know dy dt when the foot of the ladder is 3 feet from the wall, when x is exactly 3. All right. Now the equation that's going to model what's going on is going to be the Pythagorean theorem, because I have a triangle. So I have x squared plus y squared equals 12 squared, right? The length of the ladder is not going to change in this problem, so I can go ahead and plug in 12. Now I'm going to take the derivative. I have 2x dx dt plus 2y dy dt equals 0. All right, now I have the length x. I need to know the length y when x equals 3. So I have a 3 squared plus y squared equals 12 squared. So y squared equals 144 minus 9. What is that? 135? 135. So we're going to just leave it for right now as the square root of 135. and we're looking for dy dt. So I'm going to plug everything else in. So I have 2 times 3. Dx dt is also 3, plus 2y, 135, dy dt is what we're looking for, equals 0. So 2 square roots of 135 dy dt is equal to negative 18. And dy dt is equal to a negative 9 over the square root of 135. Now we're moving down, so that distance is getting shorter. So I should get a negative answer. So 9 divided by the square root of 135. I get 0.7745966669. They want us to round to the nearest thousand. So I should get 0.775. So dy dt is 0.775. All right, next question is find the derivative of the following function. All right, so let me just remind you, if I have e to a function, I'm calling it u, the derivative of that is the derivative of whatever's in the exponent, e to the u, right? So my exponent is x square roots of 9x minus 16. So I need to take the derivative of that exponent. And notice that that is a product. So I'm going to have to use a product rule. So I'm going to go ahead and just rewrite this function. And I'm going to write this as 9x minus 16 to the 1/2. Right, so the first thing I'm going to do is I'm going to take the derivative of that exponent. So the derivative of the first, I'm saying x is the first, and the second is the 9x minus 16 to the 1/2. So the derivative of the first is 1 times the second, 9x minus 16 to the 1/2, plus the first, now times the derivative of the second. We're going to use the chain rule. Bring the 1/2 down in front. Then 9x minus 16 to the negative 1/2 times the derivative of the inside. And then e to the original exponent. And that's it. I probably just, because it bothers me, would probably clean it up like this. I would write it as 9/2 x, 9x minus 16 to the negative 1/2. And just a reminder to make sure that you have these brackets or parentheses, it doesn't matter. But if you don't have those there, then this part right here, the original exponential function, is not going to be multiplied by both terms. All right, so make sure those are in there. All right, now I saw all kinds of answers on this one. A lot of people remembered that if I want to take the derivative of the natural log of u, you get the derivative of the inside over the inside. All right, which is true. But the derivative of this inside is like heinous, right? You have the product rule. You have to use the quotient rule. Then in the quotient rule, the numerator, you're going to have to use the product rule and the chain rule, right? And the derivative of the denominator, you also have to use the chain rule. The idea on this one was to use logarithmic differentiation, meaning what I want you to do is use your laws of logarithms to rewrite it and then take the derivative, right? So I can rewrite this as, let's just separate the product. So 5x plus 3 plus the natural log of x plus 6 cubed, and then subtract the denominator, the natural log of 1 minus 8x to the 4th. Now, let's bring the exponents down in front. So 4 natural log of 1 minus 8x. All right, now use that I can take, if I'm taking the derivative of the natural log of u, the derivative of the inside over the inside. Okay, so I'm looking at this first term, the derivative of 5x plus 3, the derivative of that is 5 over the inside, 5x plus 3, plus 3, the derivative of the inside of x plus 6 is just 1 over the inside, minus 4, the derivative of 1 minus 8x is negative 8 over the inside, 1 minus 8x. So 5 over 5x plus 3 over x plus 6 plus 32 over 1 minus 8x. All right, and that's a lot easier than quotient rule, product rule, chain rule. All right. Oops. Next question. Compute the derivative. And this is another one that you should use logarithmic differentiation. So what I'm going to do is I'm going to let y equal x to the 8th. All right, I have a variable raised to a variable. So what I'm going to do is I'm going to take the log of both sides. I'm going to take the natural log of both sides. So natural log of x to the 8th. All right, I'm going to use the law of logarithms, which means I can bring the exponent out in front. And now I'm going to take the derivative. Right, so the left side is in terms of y. So I'm going to use implicit differentiation, 1 over y, dy dx. Now this right side, I have x to the 8th times natural log of x, right? That's going to be the product rule because I have a function times a function. So the first is going to be x to the 8th, the second is going to be natural log of x. The derivative of the first is going to be 8x to the 7th times the second, natural log of x, plus the first times the derivative of the second. The derivative of natural log of x is just 1 over x. All right, now I want to solve for dy dx, so I'm going to multiply both sides by y. So dy dx equals y times 8x to the 7th natural log of x, and then x to the 8th times 1 over x is just going to give me x to the 7th, right? But I want everything in terms of x. So what is y? Well, y was my original function, so x to the 8th, 8x to the 7th natural log of x plus x to the 7th. And that's my derivative. Now they did some factoring, which is fine, but this is also fine. All right, next question. This one is find the derivative of the function. And I'm again going to use the product rule because I have a function times a function. I'm going to rewrite this function here. Q of y equals 6y squared 4y squared plus 1 to the 7/6. All right, so I'm going to take the derivative of the first, which is 12y, times the second, plus the first times the derivative of the second. We're going to have to use the chain rule. So I'm going to bring the 7/6 down. 4y squared minus 1. Subtract 1 from the 7/6, which gives me a 1/6, times the derivative of the inside, which gives me 8y. All right, and then probably what I would do is at least cancel these two 6's. So I have a 12y, 4y squared plus 1 to the 7/6. I have an 8 times 7, 56. A y squared times y cubed. 4y squared minus 1 to the 1/6. And that's how I would leave it. I think they did some factoring, but I think that's fine. All right, next question is find dy dx. So here's my function, or here's my equation. All right, so we're going to take the derivative implicitly. And again, we have e to the u, and the derivative is u prime e to the u. So I'm going to start by taking the derivative of the exponent. So the derivative of x cubed y. So I'm going to take the derivative of x cubed, and I'm going to get a 3x squared times y plus x cubed, and the derivative of y is 1 dy dx, e to the x cubed y. The derivative of 7x is 7. The derivative of 4y is 4 dy dx. All right, let's go ahead and distribute this e to the x cubed y on the left so that I have a 3x squared y e to the x cubed y plus x cubed e to the x cubed y dy dx equals 7 plus 4 dy dx. Now everything with a dy dx, I'm going to put on the left side. Everything without a dy dx, I'm going to put on the right side. So I have an x cubed e to the x cubed y. Whoops, that y should be in the exponent. Oops. Okay. X cubed y dy dx minus 4 dy dx equals 7 minus 3x squared y e to the x cubed y. Now I'm going to factor out a dy dx. And I get an x cubed e to the x cubed y minus 4 equals 7 minus 3x squared y e to the x cubed y. And now we just need to divide to solve for dy dx. So dy dx is equal to 7 minus 3x squared y e to the x cubed y over x cubed e to the x cubed y minus 4. And that's it. All right, next question. For the cost and price functions below, find the number Q of units that produce the maximum profit, the price per unit P that produces, did I not just read that? Produces the maximum profit, and C, the maximum profit. Oh, one of them is price. Oh, yeah, so one of them is price. Okay. So I have a cost function and I have a price function. All right, so part A asks us to find the maximum profit. Okay, so if I want to find profit, I need revenue minus cost, right? So profit is revenue minus cost. All right, now my revenue function is going to be P times Q minus C of Q. So 61 minus 2Q times Q minus 70 plus 13Q. So I have 61Q minus 2Q squared minus 70 minus 13Q. So P of Q equals 61 minus 13. So I have a negative 2Q squared plus 48Q minus 70. So here is my profit function. And part A asks us the number Q of units that produces our maximum profit. So now we want to take the derivative. And I get a negative 4Q plus 48. I'm going to set that equal to 0. And that means 4Q equals 48. So Q equals 12. We should really make sure that that does give me a maximum. If I take the second derivative, whoops. If I take the second derivative, that gives me negative 4, which means that it is always concave down. So that critical point must give me a maximum, right? So I know that Q equal to 12 gives me my maximum. Part B asks the price per unit that produces the maximum profit. So now I'm going to plug in 12 to my price function. So 61 minus 2 times 12. So 61 minus 24. And I get 37. And part C, the maximum profit. So now I'm going to plug that into my profit function. So I get a negative 2 times 12 squared plus 48 times 12 minus 70. So that looks odd. It's all right. Okay, so 144 times negative 2 plus 48 times 12 minus 70 gives me 182. Uh-oh. Let's try that one more time. So 12 squared times negative 2 plus 48 times 12 minus 70, 218. So my maximum profit is 218. All right, next question. Find the equation of the tangent line at the given point on the following curve. All right. So here's my equation. Natural log of x plus y equals x squared y cubed plus natural log of x squared plus 1 minus 1 at the point 1, 1. Okay? So let's start by taking the derivative of the first term. So I'm going to take the derivative of the inside, which is 1 plus dy dx over x plus y. Now I'm going to take the derivative of x squared plus y cubed. So the derivative of the first, 2x times the second, plus x squared times the derivative of the second, 3y squared dy dx. Now the next term, natural log of x squared plus y, is only in terms of x. So I'm going to take the derivative of the inside, which is 2x over x squared plus 1. And then minus 1 is just a constant. So the derivative of that is just 0. All right, next I am going to separate the left side into 2 fractions. So I have 1 over x plus y plus 1 over x plus y dy dx. All right, so equals 2x y cubed plus 3x squared y cubed dy dx plus 2x over x squared plus 1. Now, dy dx evaluated at 1, 1 is the slope of my tangent line. All right, so I'm going to go ahead, instead of solving for dy dx, which you can do, I'm just going to go ahead and plug in my point, because it'll make it a lot easier, and just change dy dx to my slope. All right, so I have a 1 over 1 plus 1 plus 1 over 1 plus 1 times m equals 2 times 1 cubed plus 3 times 1 squared times 1 cubed times m plus 2 over 1 over 1 plus 1. Okay, so I have a 1/2 plus 1/2 m equals 2 plus 3m plus 2 over 2, which is 1. All right, so let's see here. On the right side, I have a 3 plus 3m, it looks like. 3 plus 3m. Yeah. So let's put 1/2 minus 3 equals 3 minus 1/2 m. Right, and then we just need to solve for m, and that's going to give me my slope of the tangent line. All right, so 3 minus 1/2 is 6, minus 1 is 5/2. So 5/2 m equals negative 5/2, right? Yes. So my slope equals negative 1. All right, and I'm going to plug into y equals mx plus b to find my y-intercept. So 1 equals negative 1 times 1 plus b. So 2 equals b. So the equation of my tangent line is negative x plus 2. And that's it. All right, our next question is to use this chart, and it is finding the derivative of f composed with g and g composed with f. So if I am finding the derivative of f of g, of f of g of x, right? That's the chain rule. That means I'm going to take the derivative and plug in g of x times g of x. And the first part, they want it at x equals 1. So I want, see, at x equals 1. Now let's put it here. So I want f prime of g of 1, g prime of 1. All right, so I'm looking at 1. So g prime of 1 is 8/9. And g of 1 is 2. So now what I want is f prime of 2, which is negative 4. So I have negative 4 times 8/9, which equals negative 32 over 9. So that is part A. Now they want us to do part B, which is g composed with f at x equals 4. So now we want the derivative with respect to x of g of f of x. So they want g prime of f of x, f prime of x. That's our chain rule. So at x equals 4, We want G prime of F of 4, F prime of 4. So let's go to 4. F of 4 is 4, and F prime of 4 is -8. So now I have G prime of 4, and F prime of 4 is -8. Now I want G prime of 4, which is 2/9. So I get 2/9 times -8, which is -16/9. And that's it. And that may be the last one. That's it. All right.